So for this section, we're gonna integrate rational expressions. I got excited. I don't know why I got so excited. But it's not so bad. It's just we gotta remember stuff from Algebra 2. I'm pretty sure that many people don't remember, so that's what this is gonna be, kind of a review. I'm gonna do two examples for this part, even though there's only one problem that deals with this, and that's number 5. So let's take a look at the first example. So I have a rational expression. Rational expression just means it has a fraction. And what am I gonna do? How do I integrate this? I can try use substitution. It won't work. Maybe you can pause it and try real quick and see that it won't work. You could try to make it a product. Make it a product and do integration by parts. What do I mean? You could, I guess, write it like this. I'm not gonna do this because we're in a new section. I mean, it might work. I don't know. I didn't try it. Maybe this is U. This is dv. Could work. In fact, what I plan on doing, I don't even know if that's gonna work. So this might be a waste of a video, but if it is, then you'll never see it. So let's see. What I would do first is split up the numerator. So I would say first I would have the integral of x over x plus 4 dx plus the integral of 3 over x plus 4 dx. Now immediately I think, I could use substitution on that one. That one would work. Yeah, I could do it. I'll do it. Actually, I'm going to do that first. And then I'll work on this, and then we'll supplement our answer. So, first thing that I'm going to do is take a look at this. So, first, I split up the numerator, if you can. So that's what I did. So, split up the numerator. And then that integral is the same thing as 3, and I'm going to do it in red. Ooh. So we have that plus there. I'll just circle it. So I have 3 integral 1 over. I'm just moving the 3 out in front. Plus 4 dx, and I'll take the long way to do this, but later on I'll use it's a shortcut. This is going to be the natural log, but I will say u equals x plus 4 du equals dx. Very good, very good. And then I have the 3 and 1 over u. That's nice. Dx. And I feel like a lot of people don't remember this, so it's a good thing that we're going over it. The integral of 1 over u. That would be the natural log of the absolute value of u. And then plus c. Right? Let's just check this real quick. I feel like more people remember this. ddx of the natural log of x. That gives you 1 over x. If you tried to integrate 1 over x, this is the way I remember it. If you tried to integrate 1 over x and you made it like this, you're supposed to add 1 to the exponent and then divide by, you're dividing by 0. That's how you know you get back to the natural log of x. And I actually don't remember the integral of 1 over u. I just remember that the derivative of the natural log of x is this. So if I'm integrating this, it goes back to that. So definitely something to remember. Add to your list of, I suppose, integral of 1 over x. That you should add to the list of things that you're memorizing. Hint, hint, hint. Hint, 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 hint. Rin, tin, tin. And then I'm going to change the u back to whatever it was, which was x plus 4. X plus 4. And then plus c still. So that was easy. And later on, I'm just going to look at that, think about the u substitution, say, yep, it'll work, and then just write that. So be aware of that and how I did it. If not, rewind it, see. I talked about it right there. So that's that part, and I'll just leave that boxed off in red. Now I gotta figure out this part. I'm gonna do this in blue. I'm thinking like, what? What is this? This is crazy. So I have x over x plus 4. U substitution will not work. And this is what we end up having to do. We have to divide using polynomial long division. What? Are you crazy? I don't remember that stuff. I do, because I just taught it in Algebra 2. So we have to use long division. Actually, anytime the numerator is of greater degree or equal to degree, we can use long division. So maybe write that down. Pause it, rewind it, write it down. Anytime the degree of the numerator, in this case 1, is the same or greater than the degree in the denominator, then we can use long division. What is that long division? What does that mean? Who is this long division? Well, let's remember what long division says. So if I divide something, x by x plus 4, the top number, just if I were to divide like 12 by 4, 12 would go inside the box, 4 would be outside, and then I think like, what times 4 gives me 12? And then I'd say, oh, that's nice. I can just say that it's 3 and everything's good to go. But what if it was like a 14 and 14? A 14 divided by 4. Okay, well, that's okay. I can say this is 3. It's a 3 there. And that still gives me 12, and I subtract them. And that gives me 2, the remainder of 2. So I have 3 plus 2 over 4, which is the same thing as 3 plus 1/2. So it's 3.5. That's nice. Okay, so I'm going to do all of the same steps with my x divided by x plus 4. I will take the top thing and put it in a box. So that's x, and this is x plus 4. And I think to myself, what times the first term gives me x? In this case, it's really easy. It's just 1. It's just 1. Crazy. So it's just 1. And so I go 1 times x gives me x plus 4. But now I need to subtract. So I change the sign. Doot, doot. And I subtract. The x and the x cancel. And I get a remainder. I get a remainder of negative 4. That's my remainder. So just how I wrote this, I'm going to write 1 plus the remainder, negative 4, over the divisor, x plus 4. Crazy! It's this crazy talk over here. Do you understand that? Polynomial long division? Maybe I'll link a polynomial long division from algebra video. Yeah, I might, if I can find it. But that's how you do polynomial long division. You always write that's called the quotient. That's the answer. This is the remainder, and you always write it over the divisor, just like we did here. So I divided that, so this integral can be rewritten as 1 plus negative 4 over x plus 4 dx. And now I could do some fancy stuff. I could do this, I could do that, and then we'll say minus 4. So I took the 4 out also while I split up the integral. X plus 4 dx. Look at that. Look at that, Daisy. Huh? Yeah. See? What? So now I can just do this rather simply. That's just x plus c normally, but and then this I can use u sub, and it will end up being, you can try it if you don't believe me. Yeah. There we go. I was thinking about the word believe, and like believe me. I was trying to make a joke with leaves, but didn't happen. So I have that. Oh, I have 2 plus c's. They really kind of get absorbed into one another because they're just. Oh, and then the plus. I circled it, so I know it's a plus there. So I have actually x minus 4 ln of x plus 4 in absolute values. Oh, I got two of them. Plus 3. I can combine stuff. I actually probably didn't need to split things up like I did, but doesn't matter. It's done. It's a done deal, Johnny. So then I get x minus a single one of these, because I have negative 4 plus 3. So that's just negative 1. ln of x plus 4. I think I might have made that more complicated than it needed to be, but there you have it. You probably could have just divided by, like, straight away, just like that, divided. But I wanted to split it up so that you could see that, and also that. So, there you go. That's the answer. So anytime you're integrating a rational expression, and you have the degree in the numerator, and it's larger or equal to the degree in the denominator, then you can use long division. And then it makes it super easy. Okay, we gotta go next video.